Hello everyone, I hope everyone is safe and doing good. Welcome back to my channel Trick or Treat with Mathematics. So far we have seen various concepts of functions in detail in my previous videos. I will link the playlist up here if you haven't watched them yet. So in today's video, we will see different types of functions. ONTO surjective function, bijective function and also inverse function. If you are new to my channel, hi, I am Deepthi. Welcome to my channel. This channel is all about mathematics and I will cover the concepts related to a particular chapter or a particular topic in detail so that it will help you understand how and when to apply these concepts fundamentally. Please consider subscribing to my channel for such in detail and amazing maths videos. Without wasting any more time, now let's jump right into the video. So now what is a surjective or an onto function? If you say there is a function from A to B, here A, B, C, D here and E, F, G, there should be at least some value in A for all the values in B. That means you should not leave any value like this. If this is not a surjective because we are not covering this, all the values in the codomain should have a mapping that exists in the domain. You can't leave this alone. That is a surjective function. So in short, we can say that the function f from A to B is a surjective function if there exists B belongs to B or there exists some A that belongs to A and f of A is equal to B. This is a surjective or onto function. In here can say that its codomain should be equal to range. All the values in the codomain should have its corresponding value in the domain. That is a surjective function in short. So what is an example of this? So if you say f is a function from n to n, then f of x is equal to x plus 2, right? Then do you think this is a surjective or not? Yes, because here we are taking x as natural numbers. And what are you getting the result? If you add a natural number to 2, then you will get a natural number only, right? We are not considering some negative or positive, isn't it? So here we are only considering a natural number that starts from 1. So that means if you add a natural number to 2, then you will get another natural number. That is within the codomain itself, isn't it? So in this case, f of x is equal to x plus 2 is a surjective function. Okay, however, if you say f is a mapping from real numbers to another real numbers and f of x is equal to x square, then do you think that this is a surjective? This is not a surjective. Why? Because we put negative x, positive x here. We get what? 4 here and we also get 4 here. But we have defined this for all real numbers, right? But we always get positive numbers when we put f of x as real numbers. Square of a number is always positive, isn't it? So that means the output is always positive, but we left out the negative values. So that means the range that you are getting positive is not covering the codomain real numbers. It's only covering a part of the codomain. That is the reason why this is not a surjective. Okay. So this is all about surjective function. Now with this knowledge of surjective and injective function, what is a bijective function? Bijective function is the combination of surjective and injective function. That is, a function f is defined as a bijective function if it is both onto and one on one. In this case, the bijective function example can be f from r positive, that is r. This is positive real numbers. F of x is equal to x square is a bijective. Here we said even f of x is equal to x square from f normal real numbers, no restriction of positive and negative. We told that it cannot be a surjective and it cannot be an injective both, if you remember. But if you define this from positive real numbers to another positive real number, then it can be a bijective, because if we input positive, we get positive value as an output. So that means the output of this function will be positive real numbers only. It is tying up with the codomain that we've defined? Yes. So that means in here, f of x equal to x square is a bijective function. That is nothing but it should be both 1 on 1 and onto. Okay, now let's see whether this function f of x is equal to 2x minus 3 is a bijective or not. What is bijective? You know from the definition of bijective, it should be an injective function or one-to-one function, and it would be a surjective function or onto. It should be both. How do you prove whether this function is a one-on-one function or not? You need to show that f of x1 is equal to f of x2, then x1 is equal to x2, right? So now let's put this as f of x1, you get what? 2x minus 3. What is f of x2? You get 2x2 minus 3. Now equate them. 2x minus 3 is equal to 2x2 minus 3. Cancel 2, then you will get x1 is equal to x2. That means you can say that f of x is equal to x minus 3 is one-to-one function or an injective. How can you prove that whether it's a surjective or not? Consider that you know for a fact f of x is equal to 2x minus 3. This you consider as y. What do you get? 2x minus 3. So you get x as y plus 3 by 2. Right. So if you get x as y plus 3 by 2, that means this value is a real number. Right? And you know for a fact that here x is also a real number, and you should get y as a real number. We assumed f of x is y here. That means this is y. Right. So this is a real number and this is a real number here. Hence you can say that this is a surjective function. We are getting everything within the codomain that we have defined. So in short, because this is injective and surjective, can you not say that f of x is equal to 2x minus 3 is a bijective function? Yes. Hence, this is how you show whether a function is bijective or not. This can be applied to all other problems as well, but this is the basic that you need to understand. Okay, now I've told you that a bijective function is both surjective and injective. However, a bijective function can also have an inverse function. How do we define an inverse, and what is the concept of inverse function? Let's now see that. Here I have defined a function from a to b such that this is a bijective function. Yes. Inverse of a function exists when a function is a bijective function, or vice versa. If a function is said to be an inverse function, then it is a bijective function. But what is this meaning of inverse? Here we have established the relationship from a to b, right? Inverse will be like this. We say this is a to b, and if we say 1, 2, 3, 4, 2, 3, 4. Remember, it should be bijective. We'll say that the inverse of a function is this. Okay, that means here inverse of a function b assigns every element of b to a unique element in a. That is the inverse. You define the inverse. If you say f of a is equal to b, then inverse of this function will be f inverse of b is equal to a. Okay, so this is the definition of an inverse function. Why did I say that the inverse function should have or should be a bijective function? I'll try to show you why it should be a bijective function now. So, how can you say that an inverse function is a bijective function or not? How do we prove this? Let's now assume that there is a function from a to b which is not or one-to-one. How do you say that? If you say there are 3 values here and there are like 4 values here, we'll say this is mapped to this mapped to this mapped to this. So this function is clearly not a one-to-one function. The reason being, 2 elements have one element, 2 elements are mapped to 1 here. So it's just a function, right? Assume the inverse of this function. What is the inverse here? Inverse will be this. Can you see that when you take the inverse, this particular element is having 2 elements in domain? So, is this a function first of all? No, because a function will not have one element mapped to two images, it will only have one image, right? So this is not a function. Hence, you can say that for a bijective or for the inverse to work, it should be a one-to-one function. Now, if we assume that this function is not a surjective function, it means you can just say like this. Okay, and if you do the reverse now, you can see that one element is mapped to three elements here. That means this is also not a function, right? Yes. So, in fact, you can say that an inverse function should definitely be a bijective function. If not, there is not even a function. It should be a bijective function, right? So, this is the concept of inverse function. Now, this is how you can prove that an inverse function should be a bijective. Here I have shown you very simply using two diagrams, but you also have a mathematical proof to show whether an inverse function is bijective or not. It's similar to this same, but they just put it in terms of f of x and f of b. Okay, so now let's see a quick example on inverse function. So this is a question, f of x is equal to 2x plus 3, wherein you need to find the inverse of this function. How do we denote the inverse of the function? You'll denote this as f inverse, so and so, f inverse y, f inverse x, etc. But this is how you denote the inverse of a function. So how do you find the inverse of the function f of x is equal to 2x plus 3? You'll just say that, assume f of x is equal to y. Okay. And from here, can you not say that f inverse of y is equal to x? Just put this in order. Now, 2x plus 3 is f of x. This is equal to y. So, simplify in terms of y. So, 2x is equal to y minus 3. X is equal to y minus 3 by 2. Right? And you know for a fact that x is equal to f inverse y. So, can we not say that from here, f inverse of y is equal to y minus 3 by 2? Right? So, this is the inverse of 2x plus 3. That is how you find the inverse function. And in order to check whether this is the inverse or not, what you can do is, you can substitute this in this. That means, if you substitute x as y minus 3 by 2 in here, that is 2 into y minus 3 by 2 plus 3. If you substitute this, you need to get y. So, y minus 3 plus 3, you will get it as y. So, this is nothing but, you can say f inverse of y. F inverse of y. This is a composite function, you will understand in the next video, but this is how you can also show that the inverse of the function is this by substituting the value that you get in the original function. Okay, so this is how you find the inverse of a function. While finding the inverse of common functions, you know for a fact that plus will become minus, we have seen, right? Well, we're finding the inverse, and multiplication will become division, or division will become multiplication, because we'll take the reciprocal and do it. And x will become 1 by y. Right. So, and here you need to make sure that x and y are not equal to 0. That is f of x or f of y is not equal to 0. Because if it's 0, it's not defined. Then, what else? X square will become root y. Or if you can say x power of n will become n root y. Or you can say y to the power of 1 by n, or here y to the power of 1 by 2. Right. But these two have certain restrictions. Depends upon whether n is positive, even, odd, etc. It's not always the case. There is a restriction here that you need to follow. And e power of x, and e power of x will become what? Y, because x is converting to y. And a power of x will become what? Log y to the base a. Here we need to make sure that y is greater than 0. Here also y is greater than 0, and a also should be greater than 0, right? Because I have defined very clearly y and a should be base and the power should be greater than 0 in one of my videos. You can watch it there. And if you say there is sine x, you'll convert this as sine inverse y cos x, you'll convert this as cos inverse y, tan x, you'll convert this as tan inverse y, and these also have their own ranges, right? You can say this is from minus pi by 2 to pi by 2, and cos inverse y also ranges from, cos range from 0 to pi, and tan ranges from minus pi by 2 to plus pi by 2. So these are all the ranges that you need to know in order to convert a function from a normal one to an inverse one, in order to find out an inverse function. The restrictions that are there here are very important. You need to restrict the domain in order to find the inverse function. If not, you will not get the inverse of that function. This is all about the inverse function. So I hope you understood today's video. I've covered the concepts of surjective, bijective, and also inverse functions. If you have any questions, please leave a comment down below so that I'll be able to help you. So in the next video, we'll see some more types of functions, and in detail I'll be covering the concept of composition of a function. So if you like my video, I request you to please like, share and subscribe to my channel and ring the bell notification down below so that you will never miss an update from me. I will see you all in my next video. Until then, I hope you have a safe day and a wonderful week ahead. Bye.